We're trying to show that a pair of very large numbers are congruent. So let's review what the triple equal sign actually means. So we write A is congruent to B. Okay, and we'll go ahead just do this general mod n. The problem that we're looking at, the modulus is 187. But in general, what this means, and there's actually 3 different ways you can write, that I know of, that you can write the definition here. So A is congruent to B mod n. Now I'm going to use the formulation that we're going to use to demonstrate this. But I'll put double arrow to denote that this is the same thing as just like a definition almost. So if the difference, if A minus B, and again, y'all, the double arrow just means definition. If the difference is some multiple of the modulus, and we'll use another integer. Y'all, these are all integers. These values A and B are integers, so is the modulus. And we'll write m, little m, times n. So there's another way to think about it. This is the same thing as saying n divides A minus B. Okay. Again, another way to write this would say n divides, and you use this vertical bar. N divides in parenthetically A minus B. And there's yet another way to do it, but we won't go into that. It's about remainders. Okay, so 2 equivalent notions of what it means for congruence to occur, and the one that we'll be finding most useful for this problem is the very first formulation. Now notice factorial, by definition, 40 factorial is the same as 37 factorial. That means 1 times 2 times 3 all the way up to 37 times 38 times 39 times 40. Okay. Now that comes in handle. If you take a look at this right here, this A congruent to B turns into a subtraction statement. Okay, that's why we're subtracting right here. This minus sign you see here is coming from here. Okay. Now, so 40 factorial minus 37 factorial, they have 37 factorial in common. And notice there's an understood 1 right here, right? So I'll put 1 dot, and that's it for beginning people. A lot of times they want to know, where did this 1 come from? You know, you already took it all the way out of there, right? But this 1 and this 1 are the same thing by the distributive property. Okay, so we've written 40 factorial minus 37 factorial is the product of 2 values here. Now, if we can show that this number contains the factor 187, we'll be done with the problem. Okay, we will have verified what we set out to prove. So let's move along. Now, a little bit of work. You can multiply this out by hand. 38 times 39 times 40 minus 1 turns out to be this number, 59,279. Okay, now also what we can do here, we have a lot of information here, folks. We know that 187, see, in a way, this is almost like cheating, I guess. 187 is equal to 11 times 17. Okay. 11 times 17, that's 10 times 17 is 170, plus 17 is 187. And so what we can do right here is just, all we have to do is verify that 11 and 17 divide this number. Now down here I did long division. This verifies that 17 is a divisor of 59,279. Again, you can check out the work here. This remainder of 0 you see right here indicates that 17 is a factor of this number right here that we're interested in. Now also, you guys may have, there's another rule. Divisibility by 11 can be ascertained if you alternate these signs. Let me show you what I mean. Minus 5 plus 9 I'll write down why this works. Minus 2 plus 7 I think I got this backwards, y'all. Hang on just a second. Yeah, I did. And I'll write down the thing, and then I'll try to prove what I'm talking about here. So, folks, what I was meant to say is 5, okay, minus 9 plus 2 minus 7 plus 9. You see what I'm doing, folks? I'm taking those digits and just alternating the signs, and I'll tell you why in just a minute why that's useful. Notice that this is equal to 0 here, right here. Minus 9 plus minus 9 is equal to 0. And right here you have 5 plus 2 minus 7. So this is all equal to 0. Now, what this does, this says that, this implies, and I'll tell you why, this implies that 11 does divide 59,279. $59,279. Now the reason is this interesting looking little truism about congruences. 10 raised to the n power. And this is not too hard to verify. I'll just write it down as a fact for now. 10 raised to the n power is congruent to minus 1 raised to the n power mod 11. Now, hopefully that's convincing. It's not a rigorous proof, but you can kind of see what's going on here. So it's modulo 11. And just think of the special case n equals to 1. 10 minus negative 1. If n is equal to 1, you would have 10 minus negative 1 is equal to 11, all right? And so by properties of congruences, you can raise it to natural number powers, and it still holds, okay? But notice that this right here, this is the 10 to the 4th position, right? This is the 10 to the 4th position. Okay, so you see how that's why this was a plus right here, right? Because minus 1 to the 4th power is just 1. Now right here, this would be the 10 to the 1st position here, right, as far as this decimal number goes. And so your n would be 1, and that would be a minus sign. And that's why you have a minus sign right here associated with a 7. Okay, so anyway, we know what the upshot is that 11 does divide 59,279. We've shown that 17 divides 59,279. And so we can rewrite this. Let's see if I'm going to write small enough here. 37 factorial. Okay, we can rewrite that as 37 factorial. Okay, 37 factorial, and then we know that it's going to be times, let me put this in, yeah, that should be a 37 factorial times 11 times 17. But remember, 11 times 17 is 187. And let me put times some multiple. I'll call it capital M if you want. Okay, we don't know what that multiple is, nor do we have to know. We know 11 by this work right here is a divisor, and we know that 17 is a divisor by this long division that we did right here, folks. So this proves the result. In other words, 40 factorial minus 37 factorial is a multiple of 187. This part here is 187. Okay, so we've written the difference of 40 factorial and 37 factorial as a multiple of 187, which is what we have to do right here. In other words, if you replace, this is exactly this statement right here. Okay, n is 187 for this particular problem, right? And so we had to write a minus b as a multiple of n. This would be our n right here, right? For this more general case. So anyway, this part right here proves it. Let me get that circle. all of this stuff here is a multiple of 187. So that completes the verification.